In this video, I want to take what we did in the last video, where we started thinking about virtual pets and diagramming with UML, and I want to take this and start making the code that corresponds to this UML. So we'll see how this process of planning classes and objects translates into C# code. So we're going to use this example, and one thing that I want to emphasize before we jump into it, to just sort of refresh everyone on this. I've got a diagram that comes from another faculty member here, Janelle Baxter, and you can find more information there at coding-adventure.com or programmingisfun.com. She's got a ton of great resources for learning C#, and I'm borrowing one of her really great example diagrams here to explain the idea of classes, because that's going to be fundamental to what we do in this video. And that's what we were mapping out here with UML. We did a class diagram for the virtual pet, and then we did object diagrams for instances created from that class. So, object-oriented programming, or OOP, is a technique where we think about these classes and objects as we're designing our code. And so a class is like a blueprint or a template for creating instances that conform to that blueprint. So over here in the diagram from Janelle Baxter, we've got this blueprint of a bird, and it says that birds have crest, tail, beak, talon. So all birds have those properties. It doesn't say like what color any of those properties are, but it's saying that all birds have this. So that's our class, that's our blueprint, and then objects or instances, those are specific creations from that blueprint. So here we've got the blueprint for the bird with crest, tail, beak, talon. This bird over here is a specific bird that has pink and red crest, tail, beak, talon. And this is a different specific bird that has green crest, tail, beak, talon. And this one is specific again, but with blue beak, tail. You get the idea here. So our class is the blueprint that describes all birds. And then our objects or instances here describe specific birds. And one thing that you will see often is that we will use one class to create many objects or instances from that class. So here we've got one class for the bird and then multiple specific birds created from it, which is exactly what we were mapping out here. So our virtual pet, our class diagram, that's the blueprint. We're saying all pets have to have name, age, hunger level, species. All pets can eat, sleep, play, and speak. And then over on the object side, this is where we took our class diagram and made specific pets. We have Leo and Junior, who all, each of them has their name, age, hunger level, species filled in. And then all of them have these operations that they can perform. And we could use this virtual pet to create many more objects that all conform to the same blueprint. So it's really important to realize here that we can't just add another attribute here to Leo, and we can't just add another operation here to Leo. This object has to conform to this blueprint for our class. This will make more sense as we dive into coding this up, making our class and then creating objects from it, but just keep this general picture in mind that we're building a blueprint for all virtual pets, and then we're going to use that blueprint to kind of stamp out specific pets. So what I'm going to do here is open up Visual Studio, create a new .NET Core console application, and we're going to go into Intro to Programming here, and I'm going to call this Virtual Pet Simulator. So to get started and just to see something happening in our project, I want to do two things. I want to customize the message that's printed out here. So let's say, welcome to the pet simulator. And remember that this main function, as soon as the last line of code is executed inside of this main function, the application closes. So if I hit play right now, it's going to print out this, and then the application will, our console application will disappear. So I'm going to use console read key to keep that window open until a key is pressed. So it should say, welcome to our pet simulator. We got that. And as soon as I press a key, the window closes. We can improve this interface a little bit. What we want to do is always tell the user what's going on. So press any key to exit so that they know why the window is still open and how to close the application. Great, it's running. Press any key to exit. Pressing a key shuts it down. The way that I want to approach this is to build out our UML here step by step. So we're going to try and bite off really small features one at a time to build. Each time we bite one of those off and build it, we're going to make sure that it works before moving on to the next one. And this is the approach that I highly encourage you to take when you're coding, is to try to get small things working one at a time, fix any errors as they come up, rather than try to code everything all at once and then deal with like 50 errors at the end. That can be very overwhelming, but if you do this step-by-step, iterative building, it's much more manageable, and you also get the reward of seeing something functioning every once in a while. So the first thing I want to do is let's clean this up a little bit. I want to show you that up at the top here, if you use static system console, whoops. System.console is a class that comes from .NET that you have access to. It is a static class. Don't worry if you don't know what that means yet. But when we say using static system.console, we are saying that everything that exists within system.console, we want to bring into this project so that we don't have to say console dot everywhere. So instead, we can just say write line or read key. So if I hit play, nothing should break, should still function as it did before. We have just cut down on some of the code we had to write. And while we're at it, let's change the title and let's have it be Virtual Pet Simulator with a couple equal signs on either side to give it a little bit of formatting. There we go, Virtual Pet Simulator at the top. Welcome to the Pet Simulator. Press any key to exit. And while we're at it, let's just add some ASCII art here. So I'm going to search for text ASCII art. And the first result here is this text to ASCII art generator. I want to just have like virtual pet as the text. And I just want to grab one of these. This one looks good. So I am going to copy this text. And I am going to write line. And I'm going to use a verbatim string, which allows us to insert multiple lines of text in here. And I'm going to paste in my font. And then I think I'm just going to clean up, remove some of the white space here. Make sure I got my semicolon at the end. Hit play. All right, that's looking a little bit better already. And I could get rid of the white space at the top here by deleting from here to the start of this line. There we go. So one caveat here is that when we use the verbatim string, we can't put a double quote in here. So if you find a string that has double quotes in it, or you find a font that has double quotes in it, or you're getting a bunch of errors, just use a different font. If you can't get it to work, just don't worry about this. This is making our code slightly prettier, but it is not essential to the concepts. Okay, we got our framework. We got some text showing up. We got the window staying open. It's kind of stuff that we do for every application that we build. The next thing I want to do is start actually building out this class. So I want to create a class for our virtual pet and see what it looks like to do this process where we've got an arrow pointing from our blueprint to a specific bird here. That's called instantiation, or calling the constructor. We want to do that process for a virtual pet. So we're going to try and do it for Leo and Junior here from our virtual pet template. Back in Visual Studio, the way you can add a class, there are a couple ways to do it. The way I recommend doing is up at the toolbar at the top, hit Project, Add Class. If the top option here is not C# class, you can search for class and just make sure you're clicking on one that says C# here. And then we name the class. So I'm going to call this virtual pet. And this has added a new class to our project. We can see it over in the sidebar. And if I click on program and virtual pet, it'll take me back and forth between those two classes. And this is an empty class, so there's nothing in it yet. But we'll see the process of instantiating from this class, even with the empty class. So we don't have to add anything here yet to even use virtual pet. One thing I do want to do is show you that you can snap virtual pet side by side. So if you grab one of your windows, one of your editor windows, and you drag it around, you can see in the middle, there's this like ghost interface that allows you to choose where you want these files. So you can snap side by side virtual pet and program, so that we can keep both in our head while we're working, even though they're in separate files. In general, in C#, we're going to try and stick to one class per file, though you could technically have this class over here right above program. We're going to try putting them into separate files. And I know that that's hard in the beginning to sort of hold separate files in your head, and that's why you can snap your files side by side, so that you can actually see them both while you're working. So let's go ahead and create our first virtual pet here. And we said we've got Leo and Junior. So let's create Leo first. Leo is a new virtual pet. And let's do Junior is a new virtual pet. So we added a class, we created instances from that class. We want to make sure that this works, that we haven't made any mistakes. So two ways you can do that. You can try building your project again. Nothing new has happened here because we haven't actually done anything with the virtual pets that would make them show up in our console window. But the fact that the application ran tells us that there were no errors. The faster way to do this is if you just click on your error list down here, check to see that there are no errors, then you're all good. You know that the code you added does not cause any build errors, so we can keep working and we can go on to the next feature. It is worth pausing for a second to break down this line of code. So when we have created other variables, like we created a score variable, it looked something like this, where we had the variable type and identifier, and then we set it equal to something. That's the same thing we're doing here. So virtual pet is a new type that we've added that our project understands. So we can create variables that are virtual pets now that we have this virtual pet class in our project. Leo is our identifier. So that's a variable called Leo that we can use to refer to this virtual pet. And then new virtual pet here, whoops, constructs a virtual pet object. So this side of the equation is taking our template and stamping out a specific pet for us. So we end up with Leo being a virtual pet object. And maybe I'll tab these over. It's a little easier to read this way. So what we're doing here, it's the same formula when we were creating other variables. It's just that now we're doing it with our new type, our new class, virtual pet. Okay, let's make our pet do something. So to see something print out, maybe we'll start with the name. So this pet's name is Leo, this one's Junior, and we said that all pets have a string name field. So I'm coming back in here to my virtual pet class, and then I can say string name. And actually, let's make this public. So this is a field, and the kind of structure that we've got here, public string name. Public is the access modifier. String is the type, and name is the identifier. Let me tab these over. So that's our formula for creating a field. It actually looks a lot like the left-hand side of when we're creating a variable over here. And you can think of a field as really just a variable that lives inside of our virtual pet objects. So every pet is going to have this name field associated with it. We'll talk about this access modifier after we get a few fields in here. For now, we'll just use public, which means that we can reach in and access the name from anywhere. We'll see an example of another type called private in a minute. String, this is just our variable type. Name is just an identifier, any identifier that you want to choose. Here, you'll notice that my variable over here starts with a lowercase. This one starts with an uppercase. So the format we're going to use here when we're creating our fields is Pascal case, where the first letter of every word is uppercase. And over here, we're using camel case, where the first letter of the first word is lowercase and every word after that is uppercase. So to make that a little bit more clear, let's say Leo was a cat. So we could say that our variable is Leo the cat and Junior the parrot. So this is camel case. This is camel case. And then if we wanted, we could call this full name, and that would be Pascal case over here. Okay, so we created a spot here for a full name, for each pet to have their own name. So Leo the cat, if I type in dot after Leo the cat, I'm able to access any fields, methods, or things called properties that that Leo the cat has. So here we can already see that full name is something that I can access. So if I say Leo the cat dot full name, I'm referring to this field. So I could store something in there. I could say Leo, and then I could also print out, let's do like a little readout here of pet one, right line. My name is Leo the cat dot full name. So let me run this and then we'll break down what we did. So we've got our virtual pet title, we've got pet one, and then it says my name is Leo. So what we did here was we reached into our object to talk to the full name field. We were able to reference the full name field and store this string into it. And then later on, we were able to refer to that later, or later on, we were able to refer to this and then use it for something. So here we were just printing it out, but you could use it for all sorts of things. And I'm using string interpolation. So if I start my string with a $, I am able to then insert C# into the string here. So I can just reference Leo the cat dot full name inside of these curly brackets. So let's practice this with Junior. So I am going to take our Junior the parrot variable here and say Junior's full name is, and let's put Junior. Then we can write line, pet2, write line, my name is Junior the parrot dot full name. And while we're at it, I'm going to add some white space between each of these. So I'm just going to print out an empty line here and print out an empty line here. And maybe we'll print out an empty line after welcome. So there we go. We got pet1 printing out, my name is Leo, pet2, my name is Junior. The magic of what we did is we just created some data that is inside of our virtual pet. So we created a field here inside of our template for a virtual pet, which means that each instance has its own full name variable or its own full name field that we can access and manipulate here. So let's practice this with a few more. We saw that we wanted to store age in here, and it looks like we're doing that as an int, and we're storing species in here as a string. So public int age, public string species. And as soon as we create them here, we can see that back over in our main inside of program, when we use the dot syntax here, so Leo the cat dot, we can see that those appear. So we've got age here and we've got species. So we can set Leo to 12. Leo the cat species is cat. And we can do the same thing for Junior. Junior the parrot, age, I think we said something ridiculous like 50. Got a really old parrot, but it's a virtual game, so we can do whatever we want. So we've assigned specific values for age and species for Leo and for Junior, but we don't print them out. So we want to then modify our printing so that we can see something on the screen. So my name is Leo. I am Leo the cat.age, years old. And let's also, in that first line where we say my name is Leo, let's do comma, and then we'll put the species in here. So Leo the cat.species. And what I'm going to do to speed things up is copy and paste. So instead of Leo the cat, let's say Junior the parrot, Junior the parrot dot species, Junior the parrot dot age. Give it a run. We should hopefully see all of that printing out. So my name is Leo. Oh, you know what? I should put the word the here. So Leo comma the cat. I am 12 years old. My name is Junior. I should add the here. I am 50 years old. So let's just add the, make sure that looks good. There we go. Leo the cat, Junior the parrot. Let's look at what else we were planning on adding here. Let's add, let's actually add a Boolean that we don't have in our UML so that we can practice another data type. So here I'm going to create a public bool is awake. So this will be, in our game, we can track whether or not the pet is sleeping. So by adding the field here, then we can say Leo the cat dot is awake. let's say that Leo is awake, and let's do Junior the parrot dot is awake false. And then we can add another line that prints out here is Leo the cat dot full name. Oh, you know what? Let's just do, we'll say is awake question mark, and then we'll just print out Leo the cat dot is awake. So this is a true false value. Boolean can only be one of those two. So we'll just see true or false printing out here. I'll add a period at the end, and let's update Junior the parrot here to do the same. So Leo the cat is awake, Junior the parrot is not awake. Okay, so let's wrap up our introduction to fields here by introducing an access modifier that is private. So we're going to create a new field here, and maybe our virtual pet game involves like keeping track of the pet's experience points. And if the pet gets enough experience points, maybe they level up. So you can think of games like Pokemon or Neopets for what we're doing here. As soon as we make this field private, that means that if we were to try to access it over here, like Leo the cat dot experience points equals 10, we're going to get an error. If I hover over it, it's telling me virtual pet dot experience points is inaccessible due to its protection level. So private here means that this field is only accessible within inside of our virtual pet. It is not accessible in any of our other classes, like inside of our program class. But if we make something public, then it is accessible basically anywhere in any other class that we have in our project. So let me add, I'm going to comment this out, but leave it here. This causes an error because experience points is private. Now at this point you may be wondering, like, well, why would I make something public or private? And in general, we want to get to the place where we make all of these private by default, and we only make the things public that we are for sure know need to be public. So a field like this, experience points, may be something that we don't expose to other classes to be able to manipulate it. Maybe we want to have control over experience points, so we make it private here. But something like full name, maybe that's something that we do need to print out, like we need it in our user interface over here. So we make that public so that anyone else can reach in and read the value. Eventually, we'll get to the place of talking about properties, which are kind of like fields, except you can control a bit more about who has access, and we can make fields that anyone can read, but only our class could write or modify. So that's coming down the line. For now, just remember the difference between public and private, and that we eventually want to get to using private, but we're going to use a lot of public as we're starting out. So we've got our fields in here. This is probably good. I want to move on to the next topic, which is methods. So if we look at what we're doing with this printing out of the pet name here and the pet name, species, age is awake here, we've got a lot of repeated logic. And so we can actually use what's called a method to bundle up some of our repeated logic into reusable chunks. So I'm going to create a greet method here for virtual pets. And our greet method is going to do this. It's going to print out the name, the species, the age, whether or not they're awake. So actually, I'm going to copy and paste this and bring it over into our greet. I'm going to slide this over so that we have a little bit more room to look at our virtual pet class. And we're getting a few errors here. One It is complaining about WriteLine. It's saying it doesn't know what WriteLine is. And then it's complaining about Leo the cat. It doesn't know what Leo the cat is. So the WriteLine here, we can fix this by saying console.WriteLine, or we could come up to the top of our virtual pet and say using static system.console. And now it knows that WriteLine is referring to the console class WriteLine. The other thing we're going to do here is remove Leo the cat. So there's nothing called Leo the cat created here in our class. And in fact, if we want to refer to the full name field, all we have to do is say full name or species or age or is awake. And this is going to refer to the virtual pet's full name, age, species, is awake. So what I can do now is, because this code here is redundant, we've set it up to run over here, instead of these 3 lines of code, I can replace it with 1. I can say Leo the cat dot greet. And then if I hit play, nothing should have changed here in our output here. We still see Leo the cat and we see Junior the parrot printing out. But these 3 lines of code that are printing out come from our reusable method. And so it's reusable because we can come down here and instead of these 3 lines of code, we can replace them with just saying Junior the parrot dot greet, and give it a run. Same thing is happening here, but our code is a lot easier to maintain because these 3 lines of code are defined in a method. So we can use that for Leo, we can use that for Junior, we can use that for any other pet that we want to create. This also makes it easy if we want to change something about our greet function here. So maybe we want to put an exclamation point at the end of their introduction. All we have to do is change that right here, and it is going to update for Leo and for Junior. So if we run it, we should now see an exclamation point after them introducing themselves. So let's break this down a little bit. We've got a working method here, and this is called the method definition. And for a method, when we define it, we've got a similar thing to the field where we can say, is it public or private? If I were to change this to be private, that would mean that we can't use greet outside of virtual pet. So we should get an error over here when we say Leo the cat.greet and Junior the parrot.greet. This method I do want to be public, so I'm going to go ahead and make sure that that's public. This keyword void is the return type. Some methods will return something, and some methods won't return anything. Void is for methods that don't return anything, which is going to be where we start off learning about methods. So for now, it's okay to remember that we're using void anytime we create a method, but we'll update that mental model later. Then we have our definition or our identifier here. So this is what we're going to use to refer to this method. And then inside of our brackets here, we have the method body. So this is all dormant code that we're saying should run anytime we call greet. So when I say it's dormant code, I mean that if I come back here and let's get rid of those 2 lines of code where we called the greet function. These 3 lines of code are never going to execute. If I run it, we're no longer going to see that greet. We're just going to see pet1 and pet2, nothing printing out. So this is defining a method, and you need to then invoke that method. So when this code is running, it's going top to bottom, prints out pet1, and then when it hits this line of code, it jumps over to our definition and starts running each of these 3 lines of code. And when it's done, it comes back here and will happily continue running down top to bottom until it hits junior the parrot.greet, and then we're over here again printing out these 3 things for junior. So if we wanted to, we could create another method here. Let's look back at our UML. What did we have? We had eat, sleep, play, speak. Let's do sleep. So we can follow the same formula here. Oh, seem to have lost my cursor. Let me close this file. Open it up again. All right, cursor's back. So we're going to say public void sleep. And then we can put whatever we want in here. So maybe when we go to sleep, we want to make sure that is awake is now set to false. So is awake is false as soon as we run sleep. And then let's print something out. Let's put full name is now happily snoring. And we could throw some Z's in here. So if we come back to our code here, let's say that we want junior to fall asleep. So remember, this is dormant code. This is the definition. None of this is going to execute until we tell C# to run this code. So here we're going to say junior the parrot dot sleep. So we're going to greet, and then we're going to sleep. So you can see Leo the cat, 12 years old, is awake. None of the sleeping logic is happening here, but Junior falls asleep here under pet 2. And let's do one more. So we said eat was an operation that we might want these to do. So public void eat. And we could print out something like full name is now eating. And let's have Leo the cat eat. So Leo is now eating. Looks good. Sometimes what we want, though, is to be able to pass some information into one of these methods. So when we tell Leo to eat, maybe we want to feed Leo like some dry food. And when we have Junior eating, maybe we want to feed Junior some pellets. So we need some way to pass information into the eat function, into this eat method. So we can say like full name is now eating, and then put in whatever that food is, the food name. So our methods can accept inputs in the form of what's called parameters. So here I can create a variable. I can say string food name. This is a parameter. So what we're saying is that anytime eat is called, we must pass to it some string that's the food name, and then we can use that inside of our eat method. And you can see that now that I've said that there is one input here, so let me say one input, aka a parameter, we have an error over here. If I hover over eat, it's telling me, hey, there's no argument that corresponds to the formal required parameter of food name. And it's showing me here that eat is supposed to take one string. So as soon as we create a parameter, we now need to supply a specific value when it's time to eat. So Leo the cat here, we can say into the parentheses here some dry food. So now when eat runs for Leo, our food name is set to some dry food. So it should say Leo is now eating some dry food. Leo is now eating some dry food. And the value of these parameters is that they can change. So maybe Junior the parrot, we're going to have Junior greet, and then we're going to feed Junior, have Junior eat, let's say a worm, maybe, I don't know. And then after Junior eats the worm, Junior will go to sleep. So Leo, we can feed some dry food. Junior, we can feed a worm, and both of them are using this reusable chunk of code here. We've just made it more generic by allowing it to have an input. So let's run it. Let's make sure it works. Leo is eating some dry food. Junior is happily eating a worm. Excellent. So with methods, the next thing that I want to talk about and implement here is what's called a constructor. Right now, when we create a new pet here, we essentially have 5 lines of code to set up the pet and give it its initial state, its full name, its age, its species, whether or not it's awake. And we have to do the same thing here for Junior. With the age of 50, parrot is awake is false. That's kind of tedious when we're creating a pet. And so that's where constructors come in. They're a special kind of method, or you can think of them as a special kind of method, that runs right here. When we say new virtual pet, there is a chunk of code that runs that we can use to initialize our pet. What I'm going to typically do for ordering these things in this class is I'm going to put the fields up here, then my constructors, then any methods. So I'm going to put this here in between our fields and our methods. Public virtual pet. And now we have defined a constructor here. So the key difference with a constructor versus a method is that there is no void here. So we can't put a return type in. And the name needs to exactly match the name of our class. So let's just do a quick experiment. Or we can just do write line, pet being constructed. So whenever this function runs, we should see pet being constructed printing out. And if I zoom in here, we can see pet being constructed is printing out before pet 1, and same thing is happening here before pet 2. So as soon as we call new virtual pet, what that does is run whatever we define in this constructor. So we called it here before we print out pet 1. We call it here before we print out pet 2. This isn't terribly useful, but is helpful for us for demo purposes. So let me comment it out and I'll leave it there. What's more useful is to build on this idea of parameters that we were using here. Let's accept 4 parameters. Let's say every time we're constructing a pet, we need to know its name, its age, its species, whether or not it's awake. So I'm going to create 4 parameters here. Let's say pet name, int pet age, string pet species, bool pet is awake. And what I'm going to do is make this a little bigger so we can see all of this on one line here. So we've said that the constructor, when we're making a pet, it needs 4 pieces of information. You can see that over here we've now got errors, same like with eat, how we got errors when we didn't pass anything into the parentheses. Here we're going to need to specify 4 values for this error to go away. Let's not fix that just yet. Let's finish writing out our constructor. So it's typical to have these parameters here, and then use whatever's in those parameters to initialize our fields. So we could say our full name is equal to pet name, and our age is equal to pet age. Species is equal to pet species, and is awake is equal to pet is awake. So all we're doing is taking these 4 values, whatever's passed in, and dumping them into our fields. So I'm going to slide this over. Let's see if we can get most of this on screen at the same time. So I said string name, age, species, is awake. I need to pass those 4 things separated by commas into the virtual pet when we construct it. So here we go. Leo, comma, then the age, 12, comma, species, cat, comma, is awake is true here. So Leo, 12, cat, true. Corresponds to the name, age, species, and is awake. As soon as I do that, I don't need these 4 lines of code. So I can get rid of those. And over here for junior, I can say junior, 50, parrot, comma, false. And I no longer need these 4 lines of code. So let's try running it. What should hopefully happen is that we see the same thing. So Leo, 12, is awake, dry food, parrot, 50, worm, snoring. So it looks like everything is the same. The difference is that we have cut out 4 lines of code here for creating Leo and 4 lines of code here for creating Junior. So this has made it a lot easier for us to construct virtual pets. We can do it in 1 line. So might as well do it one more time here. So virtual pet, Callie, the unicorn is a new virtual pet. Callie, it's quite old unicorn, 250, and awake. And then we can just repeat this structure here, but instead of saying pet 2, we'll say pet 3, Callie the unicorn. And I don't know, what does a unicorn eat? Rainbows? And I'm not going to put Callie to sleep here. So if I run it, we should hopefully see Leo Jr. and now Callie. Callie's eating rainbows. So let's zoom out for a second. I mean, both literally in terms of the code to try and get everything to fit on the page, but also in terms of our concepts. So this is tricky. Object-oriented programming is hard. Don't worry if you're struggling with it. Keep at it, and the more times you go through this process, the more you'll internalize what makes sense as classes and objects. What we've done, if we go back to Janelle Baxter's image here, we've got this template for our virtual pet. It was a way for us to define some code, some features. So we've got some fields and we've got some action, some operations in terms of our UML speak, but in terms of code, they're methods that are defined for all virtual pets. We said all virtual pets have name, age, species. They can all greet, sleep, eat. And then we were able to instantiate that virtual pet and create a whole bunch of specific ones. We could create as many as we want that all use that same template. So we've got Leo, Junior, Callie, all using that same template. We can create like 50 pets all stamped out that follow this template. And all of them can greet and eat and sleep. All of them can be constructed. All of them have these fields. So you can imagine if we wanted to create a whole like zoo game, that this virtual pet class would enable us to create a lot of different creatures without having to write a whole lot of different pieces of code. Because if you imagine us approaching this naively without thinking about classes, and I wanted to create a whole bunch of pets, I would have all of these distinct variables here. Like maybe I would have pet1 name and pet2 name, etc. here. And then we'd also need pet1 age and pet2 age. So classes and objects are helping us simplify this. We don't have to have a bunch of floating variables here. We can have all of Leo's variables packed into this class, into virtual pet, and all of Junior's packed into the class. And then that also allows us to share these reusable chunks of code, these methods, across all of our pets. So there's a lot we could do from here. We could keep building out our UML. So we had said that pets should be able to play and speak. We could add some of those. We could add hunger level. We could improve the style. We didn't spend a lot of time changing like the color. We could have each pet have their own color, which would be a cool user interface thing. I'm going to leave that to you to experiment with on your own. I would say try doing that. Try adding your own methods. Try adding your own fields to make this your own and make sure you got the concepts. The last thing I want to show you is that normally what we try to do when we're writing our code in this class is we want to keep as much of the code out of program as possible. So we want to use our own custom classes. So here with our virtual pet, we got that covered. We have our own class here for the virtual pet that wraps up all of our logic for the virtual pet. If we think about what we're doing here in program, what we're doing with like creating these pets and printing them out, feeding them, we're kind of maintaining a world, like a virtual world or like a pet stable. So what we might want to do is take all of this code out of main and put it into a new class called like world or pet stable. So let's go ahead and add a new class called world. And into this class, I'm going to create a run method. Whoops, public void run. So this class will create a new world. So inside a program, what we're going to do is create a new world and call this run method. So we can put all of our logic that we want to run when our world is created inside of here. So to transform this, all we have to do is basically take all of this code. I'm going to make sure I've got it all inside of this main function, but not the closing bracket. And I'm going to cut it and paste it into run. And we're going to get a couple errors here because we don't have the using static system.console at the top. But once we fix that, everything else should work here. So now what we can do is let's collapse this so we can just see the structure here. We're going to go back to program, we'll create a new world, and we'll tell it to run, which should kick off all of our logic that's in here. So if I go back to program, I can get rid of this using static at the top, and what I can do is say world, my world is equal to a new world, my world.run. And anything we put in that run method will be kicked off and will run here. So still working. We got all our pets listed. We've got our title art. Press any key to exit. And it finishes when we press a key. So the reason why we do this is that all programs that we create are going to have this class program with a main entry point. And when we wrap up all of our logic into our own class, it becomes much easier to move code and share code from one project to another. So in this class, we're going to try and reduce how much we put into our main and offload it to our own custom classes, like we did here with world. Okay, so wrapping up, we covered a lot. We learned, we took this approach of object-oriented programming, figured out what our blueprint was, figured out a couple of instances here, and went through the process of learning how to create classes, fields, methods, and constructors. In the next video, we'll take this even further and see an example of building an application that has multiple classes that talk to one another.